Hi and welcome to Cherry Pie Math. This video is going to go over one-step inequalities or inequalities where you just have one thing you need to do in order to get x by itself. So before we get started, I want you to think about real-world inequalities. And we're doing this in a mathematical sense. I could make a whole other video about other kinds of inequalities, but I want you to think about where you've seen mathematical inequalities in the real world. And one example I was able to think of was, let's say a parking lot has a sign that says all vehicles must be less than 7 feet. And you might have seen those like when you're going into a mall and you might see like the yellow bar on the top. What are some example heights of cars that would fulfill this requirement? So let's take a look at that question a little bit more. What are some factors to consider? So we know that the car has a max height of 7 feet. And obviously we can't have anything less than that, or less than 0 feet, because that doesn't make sense. You can't have a negative car. But we also really can't have like let's say, I don't know, how high would a normal car be? Like 4 feet maybe? You can't have too short of a car either. So often we'll be using a number line to kind of illustrate the inequality. So based on these, we know that it has a max height of 7 feet, but we can also say that it has kind of like a minimum height of like 4 feet, we'll say. So if I was to do that, I would say I would put this here, a closed circle on 4 to show that's my minimum height, and I would put an open circle here on 7, and I'll show why in a second. And then on my number line, I want to show that everything in between them is possible. This is how I always drew them. I would just like put like a box on top of it, but I've also seen students just kind of put make it bolder, and that's totally fine too, as long as you can see that that spot between the 4 and the 7 is what you've chosen. And we're going to go over like how I knew to do a closed circle, open circle, etc. So some things to note, like I said, we were going to go over that. So a closed circle, if I can make this nice and closed, I'm going to write closed circle means included. Whereas an open circle means not included. And then if I was to do like this, so like I can either have like a box on top, or you can just bold it like I said before. It shows possible values. Because in an inequality, you don't actually just have like one value that you're allowed to have. It means you can have all of these possible numbers. Like I could also have said one possible height is like 5.5 feet, or one possible one is 6 feet. It can be anywhere between 4 and 7. And thinking back to those circles, I said a closed circle on 4 and an open circle on 7, because if a vehicle is exactly 7 feet, it's going to be hitting that bar. It says it has to be less than 7 feet, which means 7 feet itself is not included. You cannot have a vehicle that's 7 feet, because that would just break it, right? But you can have a vehicle that's 4 feet. That's included. It's showing the lower limit, but it's included in what you're allowed to have in your inequality. So closed circle means included, and we'll often see this with equal to, sorry. I'll put that up here. And we'll have this as not equal to. And you might remember these, for example, equal to, you have a bar underneath an inequality, whereas these are just your normal inequality values. So let's use a number line with some simple equations. To solve them with x, you really just have to pretend like it's an equal sign and then solve for x. So like, for example, in this first one, it's 4 times x is more than 20. So all I'm going to do is I'm going to divide both sides by 4. And I get x, and I have 5. And then I'm going to keep that sign in the middle, so x is more than 5. And so if I was to make a number line, I would have my number line, I'd have 5, and honestly, because there's just one number, you really don't have to have all that many things. You just have to show the numbers that matter. It doesn't have an equal to sign. Notice it's just the more than. And so any value that's greater than 5, I can put, and it's going to be an open circle. So you can do this if you want. You can do it bold, or you can go like this, and that's fine too. This is normally what I do. And that, then you're done. This is showing that any number greater than 5 will fulfill this requirement. If I can plug it in, and I will get a number bigger than 20. One trick I've seen students use if they're not sure which way to go, because we know it's more than 5, but sometimes they're like, I can't remember which way is which. Remember, more than is on the right, but if you have X on the left, if you make this into an arrow, it'll kind of show you which way to point that arrow later. I don't know. It might be helpful to you. All right, so we'll do some more. Like this one, I'm going to multiply both sides by 3. So I have X is less than or equal to -3. Because I have -1 times 3. Remember, a negative times a positive becomes a negative. And the only number that really matters is -3, and I'm doing less than or equal to. So that means it's a closed circle because it can be equal to -3. And then I'm going to put my little arrow there because I want the numbers less than. I'm going to the left. That's where my arrow is pointing. Then again, this one we just subtract 9 from both sides, and I have X is more than or equal to -5. So I draw my line. I'm going to put -5 there, and it's more than or equal to. So again, I have my closed circle because it's equal to, and then it's more than, so I can put that on that side. And then last but not least, I would add 2 to get rid of that 2 over there. And that would become X is less than 12. So I would draw my number line. I'd put 12. It's an open circle because it's not included. And then I would mark which side of the negative, or which side of positive 12 that I'm looking at. If you're not sure if you did this problem right, you're always welcome to pick something and make sure that it works. So let me just draw these arrows really quick that we had before. Here we go. Clearly I care so much about how these look. Okay, so you can always just pick a random number and make sure it works. So like in this first one, I know that like 8 is bigger than 5, for example. So if I plug in 8, so I do 4 times 8, that gives me 32, and that checks out. That is more than 20, so my inequality holds true. Or in, let's try the next one. I know that, like, let's say I choose -6, and I chose -6 because I can divide that by 3 nicely. So -6 divided by 3 is equal to -2. That checks out. -2 is less than or equal to -1. We're good. So I've double checked these, and you can do that with the other two. I'm not going to do it, but please pause the video and try to do that on your own as well. Make sure you pick numbers from the section of the inequality that we've highlighted. But wait, what happens if we have negatives? So when I say negatives, I mean like, because if we look over here, all the numbers that I multiplied by X were positive. What happens if you have a negative number? So if you multiply or divide by a negative, you flip the sign. And I'll show some examples in a second. Whereas if you add or subtract a negative, you keep the sign. The reason for that, with the adding and subtracting, it's pretty obvious. Cause it's really just because you're moving side to side, so it doesn't change anything. You're not changing the value, like the direction of the side that you care about. But with positives or with negatives, when you're multiplying and dividing, because when you divide or multiply by a negative, it changes the sign if it's positive or negative. It's going to kind of flip the direction. So multiplying or dividing by a negative changes the number line direction, basically. And that's why we would flip the sign. I could go more into this. Like, there are proofs, which are basically like fancy essays about why this works. Honestly, you just have to remember to flip the sign. That's what I learned when I was in 7th grade. It's been 20 years. Not really, but let's pretend it's been 20 years. And it's still just what I remember. If you multiply or divide by a negative number, you're just going to flip the sign. So some examples here. So I have negative 3x is more than 5. To get the x by itself, I'd have to divide by negative 3 on both sides. And so I'd have x, and this side is going to be negative 5/3. But instead of having more than, it's going to be less than. And I can see that on my number line. I'm going to have negative 5/3, and I'm using an open circle, and I'm going this way. One thing I would recommend if you're going to be picking a number to test is to convert this to a decimal. So this one would be, let's see, that's negative, what is it? I think it's negative 1.66 repeated. I might be wrong. Honestly, this is going to be super embarrassing if I'm wrong. But let's just pretend it is. Anyway, I know for sure that, like, negative 4 will be a number down here. So I'm going to test negative 4. So I have negative 3 times negative 4. And that comes out to be positive 12, which is more than positive 5. So when you plug it in, you're keeping the original sign. But when you're drawing it, you would flip the sign for your final answer. Let's do another example. So I have negative x divided by 4 is less than 12. So I'm going to multiply both sides by negative 4. Because even if the negative is in front, you can just apply it to either the top or the bottom of the fraction. It doesn't matter. Change that to my pen. So now this side is positive 4. This side is going to be negative 48. But the sign becomes more than. So if I was to draw my line, I'd have negative 48 over here. Again, it's an open circle, and then I would draw it to the right side. An example number over here would be 0. So I'm going to pick 0 because I know it's on the right side of negative 48. So if I do negative 0 divided by 4, that becomes just 0, because 0 divided by anything is 0. You can't divide by 0, but you can divide 0 by other things. And 0 is less than 12. That checks out, so I have my right thing. So just remember, if you multiply or divide by a negative, you flip the sign. If you add or subtract a negative, keep the sign. It's only when you're multiplying and dividing by negatives that you have to worry about it. So some things to remember. We just talked about this. If you multiply or divide by a negative, the inequality sign gets flipped. Closed circle means included. Open circle means not included. This is something that students mess up with all the way through high school. Just take an extra moment and make sure you have the right circle when you draw it. You can imagine the inequality as an equal sign if it helps you to solve it, but just remember to have the correct sign in your final answer. Double check your work, test those numbers. I was doing that through college. And then use the right symbol when writing your solution. Just make sure if it's been flipped or if it hasn't been flipped, make sure you're double checking it to make sure it's the right symbol. And you can do that by testing and making sure those numbers